Hello everyone, I'm Dr. Rashmi Mahajan. I'm going to explain today about the basics of the VLSI. These we are going to study under the subject HDL Digital Circuit Design. These are the few briefings which I'm going to cover in our today's session. The topics are integration. We are going to discuss on the technological advancement, then about fabrication, about design flow. These all topics are in very much, these all topics are having the uh, depth insights. However, we are going to study this topic in very short way in today's session. The pictures looking on the screen are related to the technologies which we are using in our day-to-day life. If we compare these technologies present previously, maybe earlier 20 years, the picture was different. And now let us say the example of TV. If we look toward the TV before 20 years, the picture was something different. Right now, your TV are very compact, multiple features are there. So these all is possible because of the one word which is called as integration. And this is related to the VLSI, that is very large scale integration. Title of this subject is HDL Digital Circuit Design. Now one question may comes in your mind that what is the relation of that HDL Digital Circuit Design and VLSI? VLSI is a very huge sea, and from that the content of this syllabus is related to the hardware description language, which is the HDL. Hence the specific name of the subject is given as an HDL Digital Circuit Design. However, as I told you that HDL is a part of VLSI. So unless and until you understand VLSI, you understand integration, you understand the technological advancement, fabrication and design flow, everything, once you get the complete idea of these very basic points, then we can go to the hardware description language and their other aspect, because we need to first understand what is the use of this hardware description language, where it fits into the VLSI field, what is VLSI, how the technology is getting advanced. So the question of all these questions I have tried to cover in my today's lecture. So let us talk about the integration first. In front of you, two pictures are there. One picture is the full wave bridge rectifier, wherein the circuit is given and the student can build. Of course, these diagram I have taken from the internet. The references are given on the diagram. But the important point is, look at the circuit which we have formed through the component. Other part, once you integrate the full wave rectifier on a single platform, how it looks like? Picture is in front of you in the other side. So this is the picture after integration. So I think everyone can see the difference between full wave bridge rectifier circuit and bridge rectifier IC. The main advantage of using full wave bridge rectifier IC is this IC is pre-tested. However, if you want to build a circuit from this basics, then you will need to put a lot of efforts. So efforts are reduced. Another, size is reduced. Another aspect, time required to build a complex circuit using rectifier as a component, that will get reduced. So there are multiple ways, multiple advantages of integrating different components on the single platform. VLSI does this for you. VLSI is the technology with which you can do all these things. Here I have tried to incorporate few fabrication steps. We are not going to go into the detail and depth of each and every step. That is a really different aspect. Each step has a multiple things which we need to consider. But as this is our today's introductory lecture, I'm going to tell you what is fabrication. So when we are saying fabrication, you can see that the first block, which is represented as a start block, is includes one circle, and that circle is called as silicon wafer, the platform of silicon on which you means we are going to fabricate our IC. Now, what is this oxidation, photolithography, etching, implantation? All these are the steps through which you are going to fabricate your IC on this platform. The circle is a wafer. However, you can see a small square belongs into the circle. That small squares are called as die. Just look at this. The one red circle which I have made for you, in that one red circle, you can see approximate 6 dies. Each die carries one integrated circuit. Can you imagine how small we are working? How minimum miniaturization needs into the VLSI. We are working on millimeter, nanometer, micrometer was the era maybe in 2014 roundabout. Today we are working. We are trying to go to the single electron transistor even. So these are the technological advancement into the VLSI. Taking your IC onto the wafer, that is onto the platform, it's fabrication. These are different steps. Each integrated circuit, to fabricate each integrated circuit requires different processes that we will see into the detail afterwards. Now, what is VLSI? What is VLSI? We have discussed that is very large scale integration. To integrate your different discrete component onto a silicon wafer, what requires fabrication. And to do this, your VLSI categorized into two sections. One section, it is called as phases of VLSI. In one phase, it is called as front end and other is under the back end. Very brief about the front end and back end. Front end includes functional specification, RTL, that is resistor transfer level, RTL verification. All this stuff includes under the front end part. However, back end requires physical implementation of design. Now, what do you mean by physical implementation of design? That is the actual fabrication. What we do is a static timing analysis that comes under the back end wala part. Back end part, clock tree synthesis is again under the back end. Signal integrity is again into the back end. Formal verification comes into the back end. So these all are the points. These all are the steps which we need to follow while designing our IC. I say designing, not fabricating. Fabrication, once you design it, then we will collaborate with the fab house and then fab house will actually fabricate you IC for you with these steps, So please remember the difference between fabrication and design. Fabrication means your design is ready and you are going to implement onto the wafer. This is fabrication. And designing, your circuit is ready, you want to fabricate it. So whatever are the steps required to reach up to the fabrication will come under the front end and back end part. And clubbing these two together known as VLSI design flow. So the short definition of VLSI design flow is, it is the approach to convert specifications into integrated circuits. So now we are going to see this design flow in detail. This is the design flow in which programmable logics are explained with this design specification. It is given to the, it will be converted into the design entry. There are multiple ways to have the design entry: HDL, schematic, FSM. FSM is finite state machine. Schematic, we all are know that electronic engineer will work on the schematic only. And this is the word HDL comes into the picture. That is hardware description language. And this is what the title of our subject is: HDL, hardware description language, digital circuit design. Because we are going to work on the digital circuits, we are going to work on with the hardware description language, and we are going to convert our digital circuits into the HDL code, and then we are going to do the further processing on that code, and hence the name is given. And hence I'm teaching you about the HDL and the relation between the HDL and VLSI design flow and VLSI. Okay. Now, different terminologies are included in the design flow. The few important terminologies I will highlight in today's lecture. Afterward, we are going to discuss this design flow in detail. Front-end category is there, back-end category is there, test bench is there, simulation is there. Again, the simulation has three categories: functional, gate level, timing simulation. So all this stuff we are going to see into the detail. The end output, that is download into the FPG or CPLD, this is what is the checking of our code. And today we will stop here. In next lecture, we will see the design flow in detail, each and every aspect of the design flow. Thank you very much.